There's a serious issue here, and there's a huge interest in fertiliser spreaders simply because the amount of money that we're spending on fertiliser. In the crops area, for example, with winter wheat, we're spending over €400 per hectare on fertiliser. We're also limited in what we can apply. There's legislative limits on the amount of nitrogen and the amount of phosphorus we can actually apply. And as well as that, the response to fertiliser is quite high in crops. Again, if we have an error in application and we say put on 30% less fertiliser on winter wheat, we're going to lose somewhere in the region of €180 in grain output. So it's hugely important that we apply fertiliser properly to make sure that we can use that fertiliser efficiently and effectively. The role of a fertiliser spreader is quite simply, it's really to put the right amount of fertiliser in the right place. But that sounds very simple, but in a crop situation, it can be quite challenging because modern fertiliser spreaders have to spread in the region of about widths maybe in the past 12 metres, but today 24, maybe even 36 metres. So there's a huge challenge out there in terms of getting that fertiliser placed in the right place. So there are different designs or different types of fertiliser spreader. There's the old single disc, there's oscillating spout and pneumatics, but we've really concentrated our design lately on the twin disc machine. This is the machine that nearly all tillage farmers are using to spread fertiliser. To compare machines, not all twin disc machines are the same. They're all the basic same type, but there can be huge difference in actual spreading performance. So we need to compare them by testing them. And by testing them, what we tend to do is use, normally in an indoor hall, we measure out with trays, or we collect fertiliser in trays to see that we're spreading evenly across the full width of the fertiliser spreader. And we try then and produce a figure from that gives us an indication of that evenness. That figure that we use is the coefficient of variation, or CV for short. So the better fertiliser spreaders will have lower CVs. We're talking about CVs maybe in test hall situations of being below 5%. So that's what we're targeting at, a fertiliser spreader that gives a good shaped spread pattern and that has a low CV. In recent times, we've seen huge developments in terms of bout width. You know, we have spreaders now that will claim to spread up to 48 metres wide. That's all very fine in a test hall, but achieving that in a field is really a serious task. So I think the big problem maybe in terms of fertiliser spreader development is that manufacturers are focused on the CVs that they can achieve in test hall. So the real thing that we want from modern fertiliser spreaders is that they can transfer that good spreading ability out into the field. So that's really where the focus has to be among manufacturers, to make sure that the performance in the field is matching that in the test hall. And that is a serious challenge in terms of design. The settings are very important. I think in the past farmers had a very simple spreader that had very little variation possible. But again, with the increasing bout widths, we need to be able, on modern machines, to adjust the spreader to make sure we can spread properly and evenly at those widths. And this is also a function of the fertilizer quality as well. We need to look at the fertilizer quality when setting the machine. So the farmer has, many tools depending on the spreader type. It may be the speed of the discs, it may be the type of discs that are fitted to the machine, it may be the length and the position of the vanes, it may be the height or the angle of the machine above the crop. All those can be set and varied to ensure we're getting an even spread pattern. Fertilizer quality, of course, is very important. Farmers are very aware of the chemical content of fertilizer, but the actual physical characteristics are important. What we really want is a fairly uniform particle size, a size that's maybe 2 to 4 millimetres in size range, that's rounded and that spreads evenly from the disc or the spreading element of the spreader. I think in the recent past, as people moved to bulk fertilizer, there was, if you like, less emphasis on physical quantity, but I think today farmers realise that physical quality is important, and indeed fertiliser suppliers are again looking at physical quality when they're making up the blends. Most farmers will know if they have excessively dusty products, but again the fertiliser spreader manufacturers are supplying small sieve boxes now, which will allow them to get a quick read of the size distribution of the particles in that, and they will guide the farmer then as to whether this is acceptable fertiliser, or after that it will help guide the farmer in terms of the setting of the machine to actually make the most of that type of fertiliser. So certainly the manufacturer's information is much improved in that area, and indeed they're using the internet a lot to have up-to-date information readily available for the farmer. The key messages really for the farmer are, well, number one, when you're selecting a fertiliser spreader, that by far the most important thing is the evenness that it will achieve, so that the fertiliser spreader is a design that will achieve evenness. Other issues such as hopper capacity and things like that are secondary, so evenness is number one. I think the next thing then is fertiliser quality. In other words, that they pick a fertilizer that will spread evenly at the bout widths that you're trying to work with the machine you're trying to work with. So to pick the fertilizer properly. The third thing then is really the setting of the machine. And really, as modern machines need to be set, particularly those working at wide bout widths, for particular fertilizers and for those wide bout widths. And there's a lot of help there for doing that, so farmers need to set the machine properly. And finally, maintenance is an issue as well. You cannot have worn components. The spread components, such as the discs and the vanes themselves, must be really free from wear to spread fertilizer evenly.